All right, guys, are there any questions on the homework assignment from last night? 9.1. So what we're looking at today is one of the two special right triangles. One of the two special right triangles. A 45, 45, 90 triangle is an isosceles triangle that can be formed by cutting a square in half diagonally. So we're looking at this here, and the two angles are going to be 45 and 45, and it's going to have a right angle, which is why they call this a 45, 45, 90 right triangle, or 45, 45, 90 triangle. And we have this here, so we're going to be looking at these today. Now, because it is isosceles, two of the sides are going to be congruent, and those sides are always going to be the ones that are opposite the 45-degree angles, because the sides opposite congruent angles are congruent. And we could call this x and x. And if we really wanted to find out what the hypotenuse is in terms of x, well, x squared plus x squared is equal to c squared, because c is still the hypotenuse. Well, x squared plus x squared is 2x squared. And it works out if we do take the square root of both sides. Well, the square root of c squared is c. The square root of x squared is x. And we have square root of 2. So it works out that the hypotenuse would be x squared to 2, whatever the side length is. No, the sides opposite the 45 are going to be the same. So whatever this side length is, as that one there. And it works out the hypotenuse is going to be whatever that length is times square root of 2. And really, that is what our theorem says. In a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. So the leg times square root of 2 will give us the hypotenuse. So let's look at this first one here. If that's 45, this other angle has to be 45 degrees. Because if all three angles are going to add together to be 180, one of them is 90, the other is 45, the third angle that they didn't give us has to be 45. Now looking at this here, we know that the angles opposite, the sides opposite the congruent angles are going to be congruent. So the side opposite this 45 is, so this side that's opposite 45 has to be 8. So x would be 8 times square root of 2. Now, let's find this using the Pythagorean theorem, like we had yesterday, which would be our a squared plus b squared is equal to c squared. Well, x is our hypotenuse because it's opposite the right angle. Now, at this point here, we can find out what 8 squared plus 8 squared is, which is 100 is equal to x squared. Now, at this point here, we need to square root both sides. And if I take the square root of both sides, well, the square root of x squared is x. Now, we need to figure out what the square root of 128 is. So the hypotenuse for this here is 8 square root of 2. Yeah. So this here is square root of 2. Well, what is the length of each leg? Because again, according to this theorem, the hypotenuse is the square root of 2 times as long as each leg. So we can take the leg times square root of 2, and we get the hypotenuse. So let's look at this one here. We do need to find the value of y, and we need to find the value of x. So again, this is a 45, 45, 90 right triangle. The sides opposite the 45 are going to be the congruent. They're going to be the same. So which two sides are opposite 45? And so do we know one of the variables? Which one do we know? Which is? Because these two side lengths are going to be the exact same thing. Which means we still need to find the value of x. Yes. And again, with any of these here, the Pythagorean theorem, 19 squared plus 19 squared would equal our x squared. What? 722 would equal our x squared. And again, to get x by itself, we have to square root both sides. Square root of x squared is? It gives us 19 square root of 2. Any questions on this here? Find the value of x and write your answer in simplest form. Well, we know that the missing angle that they didn't give us here is what? 45. Because this here is a 45, 45, 90 right triangle. So they told us the hypotenuse is 9 square root of 2. Yes? And we need to find the value of A and the value of, well, what do we know about A and B? They're going to be the same. Yes? And what would they be? Possibly. Let's just, since they're both the same, let's just call them x and x. And in the Pythagorean theorem, we would say that this is x squared plus x squared is equal to c squared, which is 9 square root of 2, because we're saying that a squared plus b squared is equal to c squared. Now over here we have x squared and x squared, which would be 2x squared, because we do have two of them. 2x squared is equal to, well, 9 square root of 2 squared, so we can go on and square that. And if we square that, we would get I think it'd be 162. Let's see. So 9 second root of 2. So then you'll need to go over. Okay. It's going to want 9 square root of 2. Now, yeah, it's going to want you to put that in parentheses, because without the parentheses, it's just going to apply it to the square root of 2, which isn't what we want. Any other questions on this here? What would we need to do next? Almost. Is x squared by itself, though? So we need to divide both sides by 2, because before we square root both sides, we'll need x squared by itself. 81. Now we can find the square root. So x is equal to 9, which means a and b are both 9. So what did we say the hypotenuse was? Well, the hypotenuse in a 45, 45, 90 is always what? The leg times the square root of. Okay, well, if the hypotenuse is 9 squared of 2, well, the legs have to be 9. Because the hypotenuse is what? The legs, the sides are the same, times the square root of 2. Be ready for the next one. Let's see what the next one is. Well, here they told us one of the sides is 90. We know this other angle is. And we have y. So we need to find the value of x and the value of y. Which one of these angles do we know for sure? Y would be 9 because, and they're congruent, yes, because the angles opposite, or the sides opposite the congruent angles are going to be congruent. They're going to be the same. Now, we need to find the value of x. Exactly, because for these here, the hypotenuse is always going to be the legs, the two sides that are congruent, that length times the square root of 2. And again, if we wanted to see this, we can use the Pythagorean theorem. C squared is equal to a squared plus b squared. Well, 9 squared plus 9 squared is, I think it's 162, because it's 81 plus 81. And if we square root both sides, x is equal to 9 square root of, and we get this here. Any other questions on this here? So let's look at this one here. We need to find the values of x and y. What do I know about the values of x and y? They're congruent. Yes, because the sides opposite the congruent angles are congruent, and this being a 45, 45, 90 right triangle, these two sides have to be congruent. They have to be the same. Okay? What can we do first about finding what x and y are? Or what are they going to be? And 11, because we know that the hypotenuse is what? And these two sides are the legs. They're the same. They're going to be the legs, yes? So it would be 11 and 11. They have to be the same. It works out that it's going to be 11. Questions on this here? We good with this here? So here we don't have x, we have u and v. Yeah, so for this here we don't have x or y Why? Because all it's been asking is find the value of x. I've been inserting different problems in here, so we do have a lot of different examples with this. Now here we want to find the values of u and v. Well, we know u and v are going to be 12. And how do we know that u and v are both 12? Because the hypotenuse is leg times the square root of 2. And the legs are congruent, so u and v have to be the same. We ready for the next one? Okay. So this one here is next, and we need to find the value of x and the value of y. And what would the value of x and y be here? Because 12 is the hypotenuse, and the hypotenuse is always what? Leg times the square root of, and, well, do we have a square root of 2? Okay, so let's go back to what we were doing before. We know that y and x are going to be the same. They're going to be the exact same value. So the Pythagorean theorem, a squared plus b squared is equal to c squared. And we know that a and b are the same, so we can just say x squared plus x squared is equal to 12 squared. Well, as we saw already, x squared plus x squared is 2x squared is equal to, yes, Gesundheit. Now what do we do next? Divide both sides by 2, so we get x squared by itself. So this will tell us that x squared is equal to 72. And last but not least, what do we need to do? Find the square root of 72. And x is equal to 6 squared root of 2. So that means the value of x and y here are both what? 6 times the square root of 2, yes? So x is 6 square root of 2, y is 6 square root of 2. Okay, that's kind of interesting. Well, and again, we said the hypotenuse is what? The leg times the square root of 2, yes? So we're saying that the leg's length is 6 square root of 2 times the square root of 2, yes? Leg times square root of 2. Well, here we have, if we do this, we have the square root of 2 times the square root of 2, which is what? Well, just the square root of 2 times square root of 2 would be square root of 4. Well, hopefully y'all know what the square root of 4 is. 2. Because 2 times 2 would give us 4, so the square root of 4 is 6 times 2 is 12. So this is still true, isn't it? It's still leg times the square root of 2. But does the hypotenuse have the square root of 2 anymore? Well, not really. The square root of 2 is where? In both of the legs. Questions on this here? All right, well, let's look at the next one. Five square root of 2. So how did you get to 5 square root of 2? Mm-hmm. right? And added the square root of 2. And let's check it in two different ways. One, if we say that the hypotenuse 10 is the leg times the square root of 2, yes? So if 5 square root of 2 is the leg's length, and I multiply it by the square root of 2, what should I get? I should get 10. Because this would be 5 times square root of 4, which is the same as 5 times 2, which does give us 10. Okay. Another way we can look at it is, well, I know that u and v are the same using Pythagorean's theorem. So x squared plus x squared is going to equal 10 squared. As we've seen several times already, x squared plus x squared is 2x squared is equal to 100. Well, divide both sides by 2, which tells us x squared is equal to 50. Find square root of both sides. So x is equal to 5. Which means u and v are both 5 square root of 2. Any questions on this here so far? What about this one here? Okay, change it back to 11. Yeah, I want it to be 11. I'll have to fix that later. I was looking to see what the next one was. Yeah. 12. I wonder if that got flipped. Okay. Gonna have to look back at the note sheets and see what happened. Because we had this one here for 7. There's probably 2 that went missing somewhere that I took off or something else. Because the next one's not that one. Yep. Okay, that's fine. Let's go on and look at this one here with 11, because I know I had it down as 12 for some reason on y'all's paper. Don't know why. But if we look at this one here, we need to find the value of x and y. So that one that has 12, go on and write 11 over the top of it. The other 12.
This one? Yeah. We did that. But the other 12. Oh, this. Is that what's supposed to?
It's supposed to be 11. So this one right here. This one right here. The 12. The 12 right here.
This one?
What?
This one right here is 11, but it has square root 2. It's
Okay.
like the same, but that one doesn't have the square root 2.
Okay. Yep. So I think we might be.
We're on number 5.
Yep. 7, 12.
5 have a 5.
Okay, so we're here.
Yes.
All right. That's probably what, yeah.
It's the same thing, but it's just. Yeah.
Okay. Yeah, the shape's just flipped. I'll fix that here in a minute. Yep. Know how I've got it flipped one way on the note sheets and flipped the other on the here. But, yep. Oh well. So looking at this here, we still need to find the values of. So what can we do first, or what do we know about x and y? They are going to be equal to each other. Can we do what we did on the last one? It's an odd number. Well, we can still use the Pythagorean theorem, yes? So we can say that A and B are both going to be x, because they're going to be the same thing. And our value of C is going to be 11, and we'll square it. So here x squared plus x squared is 2x squared is equal to 121. $60.5. And if we take the square root of 60.5, we get, hit the 2 arrows and see what it does for approximation. Same thing? Okay. Let's write this a little bit different, because we can actually have this with a radical. Now, did 121 divide by 2 evenly? No. I want to leave it as 121 over 2 and take the square root of it. And let's see if it'll do it. Yeah. 7.77. Okay. Same thing. Now, let's manipulate this a little bit. And in the calculator, yeah, I know. We can, but we can actually get a more precise answer. And that's kind of what I'm shooting at here. Kind of if we break it up, we actually get something interesting. Because the square root, if you type this in, you get what?
I got 11 square root of 2
Over. And I want to get at this answer for a reason. Because what did you do with the last one to get 5 square root of 2? So how did you get to 5 square root of 2? Because we had a hypotenuse of 10, and y'all gave me 5 square root of 2. How'd you get there? I mean, we did this process to get here, yes?
Yeah.
But I mean, before I did any of this, or we looked at this here, because Brian, you gave me 5 square root of 2. So how'd you get there going from 10? You did what? Right, 5 times 2 gave you 10. Or what can we say? We took 10 and divided it by, we took half of it, and we're like, okay, and then we can multiply it by the square root of 2.
11 square root of 2, but just like divided it by 10. But you can't do that since
It's not even. Because for 10, the hypotenuse being 10, is 10 divisible by 2? Yes, because 10 divided by 2 got us this here. But what else do we know about the hypotenuse? It is the leg times the square root of 2, yes? Well, our leg value here is x, so we're saying x times the square root of 2 gives us what? Well, how can I get x by itself? Dividing both sides by? Because the square root of 2 divided by the square root of 2 is? Cancels out, giving us x. So plug it in and see, what is 10 divided by the square root of 2? Okay. Square root of 2 over 2, 11 square root of 2 over 2. Well, let's look at the way we just said. Now, the leg we can call x times the square root of 2. The leg times the square root of 2 should give us the what? The hypotenuse, which is, well, I can divide both sides by the square root of 2, which tells us x is equal to what? Questions on this here? See what the next one is. Because the hypotenuse is the leg's length times the square root of 2, yes? Well, now they gave us a square root of 5. Okay, well, let's go back to the Pythagorean theorem and see what we get. So we know that the two legs are both x squared and x squared, yes? And the hypotenuse is going to be 3 square root of 5 squared. Well, here, x squared plus x squared is 2x squared is equal to, well, 3 square root of 5 squared is 45, I believe. Well, the next thing we would need to do is divide both sides by 2. X squared is equal to, well, we're going to leave it as a fraction. Leave it as a fraction so that we get our answer with our radicals, get the most precise answer we can. And at this point here, we would square root both sides. And unfortunately, for us to get a real precise answer, well, we have to plug it in as the square root of 45 over the square root of 2. Which gives us this here. Okay. So according to this here, x is 3 square root of 10 over 2, and y is 3 square root of 10 over 2. Okay. Any questions on this here? Because we're still going to look at this for a second. Well, with just the last one, we did have a little bit different way to look at this, yes? Because we're saying that also the leg's length x times the square root of 2 should give us what? 3 square root of 5, yes? Because the hypotenuse is always the leg times the square root of 2. Well, if I want to get the leg by itself, what can I do? Both sides by square root of 2. Well, these here would cancel out. Now, if we type this into the calculator, what are we going to get? 3 square root of 10 over 2. Now, that might look a little crazy for why we're getting that. But what we're doing is we're taking 3 square root of 5 over the square root of 2. And this here is not hugely important, but I think it'll help you see why we're getting there. We can't leave a radical in the denominator, in the bottom of a fraction. And as we've seen so far, what is the square root of 2 times the square root of 2? Square root of 4, which is 2. So that had simplified the denominator. Well, we're also going to multiply it by the numerator. And this seems a little weird why we can do this, but what is the square root of 2 divided by the square root of 2? Which is 1. Because anything divided by itself is. So what are we really multiplying this fraction by? 1. 1 multiplication of 1 doesn't change anything. It's just going to change how it looks. So when you typed, put a highlighter, this here into the calculator, this is actually what it's doing. It's multiplying top and bottom by the square root of 2. So the numerator, well, we'd have our 3. Square root of 5 times 2 is, and as we just said, square root of 2 times the square root of 2 is 2. So we get this here. Questions on any of this so far? As the So we would want divided by square root of 2. Because we're saying here that the hypotenuse is equal to the leg's length times square root of 2. Now, for all the problems that we've done today, we've gotten different answers, especially on the last few, yes? But as the process of what we've been doing to find the legs or to find the hypotenuse change in any way? Well, no. We still do the exact same thing, even though the numbers, like these here, came out to be really weird, but what we were doing didn't change, did it? No. And that's what's really nice with this here. That's why they put a big emphasis on these 45, 45, 90 right triangles. No matter what the lengths are, they still hold this property true. That the two sides opposite the 45-degree angles are going to be the same. And the hypotenuse is going to be whatever that is times the square root of 2. So that means if I take, actually I have a pen, 3 square root of 10 over 2, and I multiply this by the square root of 2, I should get back to what? 3 square root of 5. And if we do this here, well, the square root of 2 is going to multiply by the 10. 2 times 10 is 20. And we can simplify it because square root of 20, well, 20 is 4 times 5. Well, what's the square root of 4? 2. So really out front we have 3 times 2 times the square root of 5 divided by what? What's going to happen to those two 2's? They're simplified to 1. They cancel out, leaving us with what? Is that what our hypotenuse is? So again, these properties still hold true, even though the numbers look funky and change. But the process that we do to get from the legs to the hypotenuse or hypotenuse to the legs didn't change at all, did it?